everyone! In this video, we're going to be looking at rationalizing the denominator. So what does that mean? Why do we have to do it? Think about it in simpler terms. Rationalizing the denominator is done when you want to make something look prettier. Okay, so now you might be like, what? This is math. What are you talking about? So think about it. In the denominator, when we have a surd or root like this, it isn't really the prettiest thing. It usually it looks better if you have it if the denominator is just a whole number. So this is exactly what we're aiming to do. If we have a root or a surd in the denominator, then we want to convert it into a whole number. So this is basically the whole idea of rationalizing the denominator. How do we do that? Okay, so let's look at the first one. We have 4 over root 2. In order to get rid of the root 2, the closest whole number you could make it would be 2, right? The easiest thing to do is make the root 2 a 2. How do you do that? If you multiply the root of a number by itself, you get the whole number. And we saw that in the laws of surds. If I have root n root 2 times n, then that would give me 2. So what we're doing is, instead of raising it to the second, we're just going to multiply it by the root. So if I have root the root of 4 times the root of 4, what do I get? The root of 4 is 2 times the root of 4 is 2. That's just going to give me 4. So I think you see that now. If we have a root multiplied by the root, it gives me whatever the value inside is. So in order to make this root 2 a whole number, we're going to multiply it by root 2. Now whatever you do to the denominator, you have to do to the numerator. So we multiply the numerator by root 2 as well. Okay, when you do this, what you get is, in the numerator, the basic laws of multiplication and fractions apply. So 4 times root 2 is going to be 4 root 2. Okay, this is important. It's going to be 4 root 2 and not root 8. If this was root 4, then it would be root 8. Root 4 times root 2 is root 8. But 4 times root 2 is just 4 root 2. Okay? And root 2 times root 2 is 2. So this is basically the rationalized form. We could still simplify this. I could take away the 2 in the denominator and the numerator. So that leaves me with 2 root 2 over 1. And 1 in the denominator is redundant. So 2 root 2 would be the answer. Let's do a couple more problems. Let's look at this one. If I have 6 over 5 plus root 3, okay, how do I get this to be a whole number? Now, if I have something like this with a addition or subtraction sign in the bottom, what I want to do is multiply it by something called its conjugate. So what the conjugate basically is, it's the exact same expression, except you switch the signs. So if I have 5 plus root 3, the conjugate will become 5 minus root 3. If I have 7 minus root 7 minus 21, and that would become root 7 plus 21. So this is basically the conjugate, where you just switch the signs. So we have to multiply this by the conjugate, which is 5 minus root 3. And what you do to the denominator, you have to do to the numerator. So this is 6 times 5 minus root 3. And now you have to expand it out. 6 times 5 is 30. 6 times negative root 3 is negative 6 root 3. In the denominator, if you notice, we have 5 plus root 3 times 5 minus root 2. This is an algebraic identity where if you have a plus b times a minus b, you get squared minus b squared. So we're going to use this identity in the denominator. This is going to give us 5 squared minus root 3 squared. Okay? So that's going to be 30 minus 6 root 3 over 5 squared is 25 minus root 3 squared is 3. We saw that when you multiply a root by the root, it's just going to be the number inside, which is 3. That's going to be 30 minus 6 root 3 over 22. Okay? And you could simplify this further again. Divide all of them by 2. It's going to be 15 minus 3 root 3 over 11. So this is going to be the final simplified answer. Let's look at a final example. If I have 2 plus root 3 over 2 minus root 3, so here there's a surd in both the numerator and the denominator. But what we're focusing on is still to get rid of this root from the denominator. It does not matter if it's there in the numerator, okay? So once again, we're going to multiply by the conjugate. The conjugate of 2 minus root 3 is 2 plus root 3. 2 plus root 3. And what we do to the denominator has to be done to the numerator, so multiply that by 2 plus root 3 as well. In the numerator, we get 2 plus root 3 whole squared. In the denominator, we get, again using the identity, 2 squared minus root 3 squared. Okay, and this is another identity here. It's a plus b the whole squared gives me a squared plus 2ab plus b squared. So that's what I'm going to use in the numerator, sorry. So that's going to give me a squared, which is 4, plus 2 times a times b. So 2 times 2 is 4. 4 times root 3 is 4 root 3. Plus b squared. B squared is root 3 squared, which is just 3. That over 2 squared minus root 3 squared. 2 squared is 4. Minus root 3 squared is 3. So simplifying that, 4 plus 3, we're just adding like terms here. 4 plus 3 is 7 plus 4 root 3 over 4 minus 3 is 1. So this is my final answer. I can get rid of the 1. The final answer would be 7 plus 4 root 3. Okay, so this is the idea of rationalizing the denominator, where all you have to do is multiply by the conjugate if there is a positive or negative sign in the denominator, or like we saw in the first example, just multiply by the value itself. Thank you.